I'm going to be finishing up chapter 3, section 2. This is day 2 of this section. Okay, and what I have is y equals 9x squared plus 7, so I have a quadratic function, and I'm going to ask you a few things. First of all, it says find the minimum or maximum value of the function, then to describe the domain and the range of the function, and where the function is increasing and decreasing. So there's a couple things that we have to address here. Now, finding the minimum or maximum value, what I'm going to do is I'm just going to briefly just sketch this parabola. Since the leading coefficient is positive, our parabola is going to be open upwards, okay? And it's either going to be the very lowest point or the very highest point, and it's going to be the vertex, okay? So this is going to be the minimum. Now, to find the minimum, we actually have to find the axis of symmetry first, because we have to figure out what the location of the vertex is, okay? So to find the axis of symmetry, we have to do x equals negative b over 2a. Well, our b is 0, and anything divided by 0 is 0, so our axis of symmetry is at 0. So this is x equals 0, okay? And to find the vertex, 0 is our x value. We just have to plug it back into the original function, and we get 7. So our vertex is 0, 7. Now the minimum value is always the y value of the vertex. So our minimum value is 7. So that's our first one. We found the minimum value, which is 7. Okay, the next one is to describe the domain and the range of the function. Well, we've done this before. The domain for this one is all real numbers, and the range for this is y is greater than or equal to 7. Okay, so we've done domain and range. That shouldn't be too hard. Next up, it says describe where the function is increasing and decreasing. Now, you've never seen this before. And what we're going to do is we're going to use the axis of symmetry as a point of reference for us. And whenever we describe increasing or decreasing, we're going to read from left to right. So if we look from the very left, or the left side of the function, I'm going to highlight this so you can see this. Okay, if we look at the left side of the function, to the left of x equals 0, from left to right, this function is decreasing, okay? And if we look at the right side of the function, this function is increasing, okay? And that's how we read it, from left to right. So the way we're going to write this is we're going to say the function is decreasing, to the left of x equals 0, which is our axis of symmetry, and increasing to the right of x equals 0. And so that's how we do our increasing and decreasing. We look at the axis of symmetry and we read it from left to right. All right, let's do another example. Okay, this is the same thing, just a different function. We have g of x equals negative 3x squared minus 6x plus 5. So what we have to do is we have to find the axis of symmetry, which is x equals negative b over 2a. So this gives us a negative 1. Oh, and this is going to be actually opening downward because our leading coefficient is negative. Be careful on that one. And so for this one, we're going to be talking about the maximum. So we have to find the y value of the vertex for the maximum. And we found the axis of symmetry, which is a negative 1. Okay? So to find the vertex, we plug negative 1 back into the original equation, and we get 8. So our maximum is going to be 8. Our domain is all real numbers, and our range is going to be y is less than or equal to 8. Okay? And then we are going to describe where it is increasing and decreasing. And if we look at this, we read it from left to right, what we get is the function is increasing to the left of x equals -1 and decreasing to the right of x equals -1. Okay? So those are our examples for minimum or maximum, domain and range, and increasing and decreasing. Next up, we have one more form to learn. We've learned standard form for quadratics and vertex form, and now this one, what I have right here, is your intercept form. And intercept form is y equals a times x minus p times x minus q. Okay, and this one says graph the function labeled x-intercepts, vertex, and axis of symmetry. So we're going to have to find all three of these. Well, to find our x-intercepts, we take p, comma 0 and q, comma 0. And to find the axis of symmetry is x equals p plus q divided by 2. So we're going to take all this information and we're going to use it to graph. Okay, so the x-intercepts of this function are -1, 0, and 3, 0, because we take the opposite. Since in the intercept form we have x minus p, and the x-intercept is a positive p, we're going to change the sign. So we have a -1 and a 3 as our intercepts. So I'm going to do -1, 0, and 3, 0. And always when you have a parabola, points are equally distant from each other, and the axis of symmetry is in the middle. And to get the middle of something, we add them up and divide by 2. So we're getting the average or the middle, so that's why we do p plus q divided by 2. So for this one, the axis of symmetry is x equals -1 plus 3 over 2, which equals 2 over 2, which is equal to 1. So our axis of symmetry is at x equals 1. Okay. Now that we know that our axis of symmetry is 1, we can find our vertex by plugging in 1 into the original equation, the original function, and we get -4 when we plug that in. So we're going to graph 1, -4. Okay, and just to get one more point in there, or two more points in there, let's do a table of values really quickly. I'm going to pick 0. Let's pick 0. So if we plug in 0, that's 1 times -3, which is a -3. So let's do 0, -3, and reflect that. And then we've got our parabola using our x-intercepts in intercept form, and we've labeled our intercepts, our axis symmetry, and our vertex as well. Okay, I have another example for you. This one looks a little bit different. It looks like vertex form, but it can be written as intercept form as x minus 7 times x minus 7. Now this one is special because our x-intercept, which is 7, 0, and our axis of symmetry, which is 7 plus 7 over 2, which is 7. Let's graph that first before I show you what happens. So let's graph our x-intercept, which is at 7, 0. And then our axis of symmetry goes right through that. Now, since the axis of symmetry is going right through that intercept, that means that intercept is also our vertex. So this is special because our x-intercept and our vertex are the same. So that means we need to use a table of values to get more points. This means it's just touching once at the x-axis. So I'm going to use a table of values for this one. Okay, and let's see what we want to do here. X, and then we have 4, x minus 7 squared y, and then I'm going to try 5 and 6. I think this is going to go off the graph. So we have 4 minus 2 squared, and then 4 minus 1 squared. And this is going to be a 16 and a 4. So let's graph 6, 4. 6, 2, 3, 4, and then reflect it. And of course, the 5 is going to be way up here somewhere. It's going to go off my graph. That's why I use graph paper for these, so we have more room. So we can just use a table of values to find our 4 other points and to reflect over. So that one, you see the parabola only touches the x-axis once. So this is the special case where the intercept and the vertex are actually the same. The last one I have here looks a little different. It's y equals negative 4x times x plus 7. Now, it looks like this isn't any kind of form that we've seen, but this is still an intercept form. Think of the parentheses being around that negative 4x, and nothing being added or subtracted. So that means our x-intercept is going to be 0, 0, and the other one is 7, 0. Okay, so that one's a little bit different in that aspect. And so now we can find our axis of symmetry by doing 7 over 2. Oh, this is going to be a negative 7, actually. Negative 7, because it's x plus 7, so we switch the symbol, the sign. So that's going to be a negative 3.5. There we go. Okay, so let's graph our x-intercept. So we have 0, 0, and negative 7, 0. 1, 2, 3, 4, 5, 6, 7. And our axis of symmetry is a negative 3.5. Right in between those two. Let's find our vertex. To find our vertex, we are going to plug in a negative 3.5 to the original function, and we're going to get 49. So I'm going to say that my y values are going to go up by 7s, okay? So 1, 2, 3, 4, 5, 6, 7. Okay, and then we can connect these to make our parabola right there. And since our leading coefficient is negative and this is opening down, this matches up with our function on our graph.